So in the last video, I talked about replacing the names in the event names, strings in the event names with enums, but that the Elixir side couldn't handle it, and my experimentation in the last video was to use module and functions. However, it turns out that that can't really be used on the left-hand side of pattern matching, so you can't use it as in function heads. So I did quite a bit of refactoring to get this to work on the Elixir side, and I will walk through the changes in this video. So let me close this. So to begin with, we had these events. Let me pull this down. Let me close this. Make this a little smaller. Okay, so we have all of these events, and on the TypeScript side, there is an event name file, names file, and here we have enums. It starts with the number 1, 2, 3, 4, and as long as it retains this order, we can just edit this file, and we'll get an integer for each one of these, I guess, values, and we can use these. Anytime we use this in our code, this will be replaced with the corresponding integer. We then reproduce this into the Elixir side using this watcher. So this script uses fs_watch. So whenever the source file change, which is event names, it will write a new file into an Elixir file. And what that does is it grabs the different values here and iterates through them, producing two lists. And we call these lists int to atoms and atom to ints. And int to atoms is this Elixir function, which will say, give me an integer and I'll return an atom, which is the atomized name of the event given the integer. And then the reverse is true. So given the atomized name, it will return the integer. And so what we'll have here is two lists, and we'll dump them out here because you want all of the function heads that are similar to be next to each other. And so what that looks like is here you get these two sets of functions. So we can use this on the Elixir side, because the approach that I was taking before with module and function names is they can't be used in pattern matching, but symbols can be used for pattern matching. So we'll just use the symbol, and anytime we need to exit the boundary from Elixir into JSON, then we'll do a conversion. So we'll do a conversion coming from JavaScript land, and we'll do a conversion going into whenever we're exiting Elixir. So we can see this in practice when we receive messages from the outside world, which will happen in the space channel, because we'll receive something that looks like where is it? Handle in event. Here we go. So what this will do is, this is the raw JSON form of the event, which will contain the integer, and we'll say space server process given that raw event here, and this will return the event atom and then the atomized version of that event. We can take a look at this. So here it will create a tuple. So we created a utility called tupletize event payload. Given that raw payload, this will return the event atom and the atomized event, and we end up passing this back as the return result. But we also pass it to the a different function head, which splits out the event atom and the atomized event here, and this is what we pass through to gen server cast. We can take a look at tupletize event payload. Here we're changing this map of string keys deeply converting it into a map of atom keys. And since we're the ones controlling this payload, we just turn safe false, so it will create new atoms. And we just stick that back in here. At the same time, we grab the m value, which is that integer, and we convert that to the atom name. So once we have that, when we're passing it to this process event, actually GenServer cast, which is our self space server. So we'll go to a handle event to look at that. So coming down to the handle cast event, we'll get the atomized event and the the atom name and the atomized event. And here we're preparing this for persistence into the event stream. So we send that to the broadcaster, but we'll also broadcast this to ourselves. So we go broadcast event. Here we're sending the, actually I'm not sure we're sending it this way. Let's take a look at broadcast event. Yeah, it takes a tuple of message and this thing. So I guess message wasn't even important here. Message doesn't seem to be used, at least not at the moment. But there's no reason to make this a tuple. So broadcast event can just send it like this. And then that will send every message we receive to everybody else, which we put it to do that maybe we want to do some future filtering on it. For example, maybe not every person needs every movement information all the time. This goes to the queue broadcaster, which will eventually end up in the writer, event writer. And over here, we're getting the events coming through here. So with this one, we can still build the events into the event stream as before. We removed some of the fields there. And every 100 events, we will batch archive those events from the table to S3. And on every event, we're also creating a snapshot. So the snapshot takes the space ID, the atom message, and just the payload portion, atomized payload portion of that event. So here if we go to process, here's where we see the real change here. This used to be a string, now it's an atom. So we're pattern matching on these things, and this payload is a lot smaller, where it used to contain the payload and the P key. Now it's everything inside the P key. And I think that's all the changes. We also, I think, modified the resolvers. So some of these, actually, we didn't have to touch this one. We changed things in the command handler. This is to process, and we just made these the atomized version of these payloads. So yeah, those are all the changes, and everything should work the way it did before.